Hello, let us look at some application of law of sine and law of cosine. Here comes the first question. So a surveyor is mapping a triangular plot of land, and then he measures the two sides of the two sides in an angle formed by these two sides. Finds that so one side is 400, the other side is 200. An angle between them is 50. So what is the measure of the third side of the plot? And then we're looking for the area. So what are we going to do? So if I were to draw a, let us say that's 200, and assuming that this is 400. So here it goes. This is 200 as an example, and that's a 400. And let us say that's the 50-degree angle in between them. Now, then to find the third side, I'm going to call that a C. For the first part, what do you realize? C squared by the law of cosine is equal to 200 squared plus 400 squared minus 2 times 200 times 400 and cosine of 50 degrees. Now, then I'm going to put that into calculator here. Let's see if you can see this. So let's look at it. So first, 200 square and then plus 400 square minus 2 times 200 times 400 times cosine of 50. Now, before I press enter, let me just check which mode I'm on. I'm on the radian mode, so I need to go back to the degree mode because the value that we are looking at is degrees. And then I'm going to press enter. So that's the value that I'm getting. Then, in order for you to get the value of C, so what I need to do is take the square root of that. Second answer. Then 311 so here we get C is equal to 311.6953, and then it just continues, but they're looking for the nearest yard, so then it'll be 312 yard. All right, let's go for the second one. They want us to find the area. How do you find the area? That's equal to 1/2 AB sine of C. So then we'll end up getting 1/2 200 and 400 and sine of 50 degrees. Then I'm going to put that into calculator here. 1/2 times 200 times 400 times sine of 50. Then I realize that that becomes my answer. Here, area, and to the nearest square yard. So 3064177 and it continues. So I'm going to have, decimal point is right over here. So that's approximately equal to 30642 square yard. Becomes my final answer. All right, let's look on to the next question. Number 2, a hiking trail is planned in the shape of triangle, side this much and this much, and then so we are given 3 sides here. So I'm going to assume that the smallest one is 2.3. and then longest one is 8.1, and then 6.2. Find the nearest tenth of a degree, or the nearest tenth of minute. So we'll do both here, degree and the minute, between 2.3 and then 6.2. So that is the angle x. Now then, how are we going to find out? So since we are looking at three sides and an angle, so we'll be using law of cosine. So then here it goes. 8.1 square is equal to 2.3 square plus 6.2 square minus 2 times. So that's what we're doing. Notice that the side opposite from the angles are the opposite side of the equation, and cosine of x. Now, then if you have to solve for cosine of x, then what's going to be happening? This one minus these two. So 8.1 square minus 2.3 square minus 6.2 square. And then I have to divide by this coefficient of cosine of x. So minus 2 times 2.3 times 6.2. Now, then here it goes. So 8.1 minus 2.3 square minus 6.2 square. Now once I calculate that's what I'll be getting, but I'll be dividing that by negative 2 times 2.3 times 6.2. And I'm going to close the parentheses to let you know that all those things are the denominator. Then I'll be getting this expression. And what I need to get is the value of x. Then I'm going to do second cosine and of the answer that I just calculated. Then I realize that the measure of the angle is 140.1. So here it goes. So x equals 140.101. But they want us to put it to the nearest tenth of a degree. So this is 140.1 degrees. How will I convert this one into minutes? In fact, it's rather simple. I'm going to show you in two different ways. So all I have to do is get the decimal point. So I'm going to subtract 140 because those are the angles already, degrees already. So either I can multiply this one by 60 because that's how you convert the hours to minutes. Same thing for degrees to minutes as well. And we get 6.08. So we get that. Then in that case, we get 140 degrees and then 6 minutes. I can do it this way. Well, let me show you another way of doing it. If you want to just look at the value here, and you can convert that into degrees and minutes by second angle. You see DMS, that's a degree, minute, and seconds. So if you have to go over here, press that, that means that what they want you to do is convert this one into degrees, minutes, and seconds. You see it does it automatically for you. Here we get 140 degrees and then 6 minutes, and exactly what we end up getting. So that was our answer. Now, the second part, let's try to get the area. Since we know the angle, I'm going to use this one to find the area. That's the first one, I guess. Second part is 1/2 AB, which means what? Two sides, 2.3 times 6.2, and then sine of 140 degrees, or 100.1 degrees. So 1/2 times 2.3, 6.2, and then sine of 140.1. Then our answer seems to be right over here, 4.57. to the nearest tenth of a square mile. So that means this would be 4.6 square miles. Okay. All right. So that's what we could have done. Let's go for the next question. Number 3. A tractor stuck in the mud and being pulled out of by two trucks. So one truck applies a force of 1,200 pounds. The other one, this much. An angle between them is this. So then what we are ultimately doing is I have one object. Obviously, in this case, it was truck. And one is pulled out this way. The other one is pulled out this way. And then, so this is 1,200. And this is 1,700. Angle between them is 72 degrees. Now find the magnitude of the resultant. So then how are we going to do it? In order for us to find the magnitude of the resultant, what we are doing is we are using the parallelogram rule. So imagine if I were to bring this one up over here. I guess you might have to do this one by hand, but I'm just putting. So as I'm making the parallelogram by copying the opposite sides, then here what I'll be getting, that red one will be my resultant. Then as you can see, this side, 1,700 is equal to the opposite side. I can bring this one up. The fact that I know that this angle is 72, that means the consecutive angles in the parallelograms are supplementary. So this becomes 108. And then opposite side, that's the resultant, x. So how are we going to do this? Once again, 3 sides and an angle, we are looking at law of cosine. So we get x squared is equal to 1,200 squared plus 1,700 squared minus 2 times 1,200 and 1,700 cosine of 108. All right, that means in this case, let's go to our calculator here. So 1,200 plus 1,700, then minus 2 times 1,200 times 1,700 cosine of 108. And that's what we end up getting, but we have to take the square root of it. So I'm taking the square root here. And my answer seems to be 23x equals 2364.4. So that means this one is equal to what? Nearest pound, so we get 2364 pounds. That becomes our answer. All right, let's look at the next question. Number 4. The forces 40 pounds and 70 pounds act on a body, and the angle measures 60 degrees. Okay, so find the measure of the resultant force nearest hundredth of a pound. So here, we're going to be drawing something similar as before, except the angle is here we get 60 degrees. So assuming that that's 40 N, that's 60. So we have opposite sides by using the concept of opposite sides being congruent to each other. So there it goes. All right, so here it goes. All right, okay. Now, and this is 40, this is 70, and this angle is 60. That tells you that this angle must be 120. But we are looking for the resultant. I'm going to call that as R. Now, since this is 70, the opposite side is 70 as well. Which law should you be using? Yes, it will be law of cosine once again. So here, R squared is equal to 40 squared plus 70 squared minus 2 times 40 times 70 times cosine of 120. So we're going to put that into calculator here. (40 squared plus 70 squared minus 2 times 40 times 70 times cosine of 120. So then that's what we end up getting, but we have to take the square root of it. All right, so then our answer becomes this one. So then R here equals 96.4365, but to the nearest hundredth of a pound, then 96.44 pounds would have been our answer. Alrighty, so let's look at number 5. The measure of the angle between resultant and then two applied forces are 65 and then 42. So then this one is a little bit different. So if I have, imagine this is a resultant, and then the red one is first force. Then I'm going to just go this way. When I clone that, then that could be my second force, creating a parallelogram. So then 65 and 42 are the two magnitudes, and resultant is 24. And I'll assume that this is 42 degrees and this is 65 degrees. I know that it's a little bit out of scale, but let us assume that it is. Then we realize that this is 65, and that tells you that this is 65 as well. And find the nearest pound, the magnitude of the larger force. Larger force must be opposite from the larger angle, which is 65. So I'm going to call this one as x. Since we know two sides, we are dealing with the two sides and then angles, so we know that we have to use a law of sines. So then I need to know the angle opposite from 24. Then we know that the angle must be coming from 180 minus 42 minus 65. Then we know that the angle is 73, so 73 degrees. And let's write up the law of sines. So here we get 24 over sine of 73 degrees, which is equal to x over sine of 65. Now we can cross multiply them or simply multiply by sine of 65 to get the value of x by itself. But we're just going to cross multiply just for now. 24 times sine of 65 is equal to x times sine of 73. So to have x by itself, I'm just going to divide by sine of 73. Then these two cancels out. Then what do we end up getting? Let's try to put that in. So 24 times sine of 65 divided by sine of 73. Then our answer is x equals 22.745. Now, then our answer is find the nearest pound. So we get 23. That becomes our answer. All right, let's move on to the next question. Number 6, two forces, and then they give you the resultant as well. Find the nearest tenth of a degree. The angle formed by between the resultant and then smaller force. So here we get, imagine that's the 50 and then this is 69. What I can do is I can clone this one. In your case, you have to just sketch that one more time. And then all right, so I'm going to mark the resultant with the red color. So here we get, this is 50, this is 69, that means this is 69 as well, and then this is 70. And then they want us to find that the angle formed between the resultant and then the smaller first, which is this one. So that's the theta. Then opposite of the angle, which is 69, should be the isolated by itself, is equal to, by using the law of cosine, 50 squared plus 70 squared minus 2 times 50 and then 70. And then we get cosine of theta. Then here you can see that cosine of theta is equal to 69 squared minus 50 squared minus 70 squared all over negative 2 times 50 times 70. So once I calculate this portion, 69 squared minus 50 squared minus 70 squared. Alright, so we get some negative number divided by negative 2, 50, and then 70. Then 0.377. Alright, so then we're going to go for second cosine of that value. So then angle theta is equal to 67.852 degrees. So then here, find to the nearest tenth of a degree, our nearest minute. So then tenth of a degree, so then this becomes 67.8 or 9, because by 1 degrees. Or another thing which you could have done was subtracting the integer portion, which is 67, and multiply the rest by 60 to convert the hour into the minute. So we get 51.1, so is equal to 67 degrees and then 51 minutes. All right, so either one would have been correct answer. Let's try to look at the next question. Number 7, two forces, 40 and then 20 pounds, respectively, acting simultaneously on an object. Angle between the two forces are 40. So we get one of them is 40, the other one is 20. And angle between them is 40 degrees. Find the magnitude of the resultant. So that's 1. And then find the magnitude of the angle between the resultant and then the larger force. So here you get this is 40, then this is 20. And you can make the parallelogram out of this. And then, yeah, I'm not sure if you can hear this sound. There's nothing going on here except that there's some fireworks going on. So sometimes you might hear the boom sound in the background, but enjoy it. All right, so here it goes. So resultant going this way. Since angle between the two forces is 40, that means this one must be 140. And this is equal to 20, and then resultant is x. So here we get, once again, x squared is equal to 40 squared plus 20 squared minus 2 times 20 times 40 times cosine of 140. Then here we get 20 squared plus 40 squared minus 2 times 20 times 40 times cosine of 140. All right, let's look at it. Then we get 3225, so we need to take the square root of that. We get 56. So x equals 56.8. And then, but in this case, nearest degree, so this will be equal to 57 degrees would have been our answer. Oh, actually, what I just found out was the resultant. So it's actually pound. So nearest tenth of a pound. So I just got the answer already here. Somehow I just misread the other portion. All right. Now after that, I want us to find the measure of the angle to the nearest degree between the resultant and then the larger force. Resultant and the larger force. That means we're looking at this angle theta right over here. Then since we know the length of the side x, so we can use a law of sine to figure out that angle. So we get 56.8 over sine of 140 is equal to, opposite of angle theta would be equal to 20, so we get 20 over sine theta. Then once again we can cross multiply them. Then 56.8 sine theta is equal to 20 sine of 140, and then by dividing, so sine theta is equal to 20 sine of 140 degrees over 56.8. So then here we get 20 sine of 140 divided by 56.8. So we get 0.226333, but we're gonna get the second sign to get the angle theta here. The answer, which we just got, so 13.08. But in that case, in case of nearest degree, so we get theta is about 13 degrees. All right, let's move on to the next question. Number 8, a farmer has determined that the crop of strawberries yield yearly profit of this much per square yard. So if you know the area, then we can calculate the profit. If the strawberry planted on a triangular piece of land, 50 yards, and then 75 and 100. How much profit? So then we get so I'm going to assume that this is 50, this is 70, and then this is a 75, this is 100. All right, then what are we going to do? Let me just try to find the value, angle x here. Now, then by doing that, we should be able to find the area using that value of x. And then once we know the area, then we can find the profit. So then here we get 100 square is equal to 50 square plus 75 square minus 2 times 50 times 75, and then cosine of x. So then cosine of x here is equal to 100 square minus 50 square minus 75 square all over negative 2, 50, 75. That's basically what we end up getting. So if you have to put that into calculator, 100 square minus 50 square minus 75 square. Oops. $75 square, and then I'm going to divide it by negative 2 times 50 times 75. And that's the value that we end up getting. And then we have to find the second cosine to find that answer. We get 104. X is equal to 104, and then 0.477, so 48 degrees. Now, but using that angle, we should be able to find out the area. So area would have been 50, 1/2 times 50 times the other side, 75, and then sine of 104.48. Then we get 1/2 times 50 times 75, and then sine of 104.48. Then the area so far gets me 1815.44 square yards. But we need to multiply that by 150. Profit now then is equal to 1815.44 times that by 1.5. Then our final answer becomes this way: 27, 23. 1.16. And then the question here in this case, nearest hundreds dollars, so that means we get about $2,700. There with the profit. All right. So now, then let's look at the next question, number 9. So one angle is 65, 70. 7, find the length of the side opposite from vertex X, vertex A. And let me call that as X, and then we need to figure out the area of the triangle ABC. So here we get X over sine of 65 is equal to 7 over sine of 70. So then you can cross multiply them if you want to, or just multiply by sine of 65 is equal to 7 times sine of 65. And divide by sine of 70. And here X equals, that's the value. So then here, 7 times sine of 65, but divide by sine of 70. So then the value of X seems to be 6.75. So that becomes our answer. And then using that side, we should be able to find the area. In order for us to find the area, because we know the two sides already, we need to figure out the angle here. But that's 180 minus these two. Then we end up getting 45 degrees. That's right. Then here we get area. Let's go to 1/2 times 7 times. The other side was 6.75. And then sine of 45 degrees. Then here we get 1/2 times 7 times 6.75, and then sine of 45 degrees. And area seems to be about 16.7. So then here it was what? Simply find the area. I guess we have done it. Okay, so with this one we're gonna stop. I'll see you later.